Hello everyone! Today we're going to go over two different methods for finding the greatest common factor of two or more numbers. First, let's talk a little bit about what the greatest common factor, or GCF, is. The greatest common factor of a set of numbers is the greatest, or largest, integer that divides evenly into all numbers of the set with no remainders other than 0. For example, if I'm looking at the numbers 4 and 6, the greatest common factor would be 2, because 2 divides 4 evenly, and 2 divides 6 evenly, and there is no other integer besides 1 that would divide both numbers evenly. With small numbers, it can often be easy to see right away what the greatest common factor might be, but as the numbers grow larger, so does the difficulty of seeing the greatest common factor easily. For smaller numbers, we can use a method called the list method. In the list method, I am going to list all the factors of both numbers I am trying to find the greatest common factor for. Factors are simply numbers we can multiply together to get another number. So some factors of 10 might be 5 and 2, because 5 times 2 equals 10. So let's use the list method to find the greatest common factor of 16 and 24. First, I am going to list all the possible factors of 16. Well, I know that 1 divides 16 evenly because 16 divided by 1 is 16. So 1 and 16 are both factors. I also know that 2 divides 16 evenly because 16 divided by 2 is 8. So 2 and 8 are also factors of 16. 3 does not divide 16 evenly, so I'm not going to write 3 down. Next, I know that 4 divides 16 evenly because 16 divided by 4 is 4, but I'm only going to write the 4 down once. I know that 5, 6, and 7 won't divide 16 evenly, and I already have an 8 down, so I'm finished with my list. Next, I'm going to list out all the factors of 24. Let's see, I know that 1 and 24 are both going to be factors. I know that 2 divides 24 into 12s. I know 3 divides 24 into 8s. And I'm running out of room, but I know that 4 divides 24 into 6. And then 6 divides 24 into 4, so I'm kind of coming full circle. Now, after I've created my lists for both numbers, to find the greatest common factor, I'm simply going to circle the biggest or greatest factor that both numbers share in common. Well, it looks like the biggest number they share is going to be a number 8. Therefore, the greatest common factor of 16 and 24 is 8. Unfortunately, this method is not ideal for larger numbers and may become confusing and time-consuming. In cases of finding the greatest common factor of two larger numbers, the factor tree method can often come in handy. In the factor tree method, I am looking specifically for prime factors. Prime factors are simply factors that are prime numbers. That is, a prime number is a number that can't be divided by anything other than 1 or itself. So let's use the factor tree method to find the greatest common factor of 75 and 100. First, let's make a factor tree for 75. So to do a factor tree, it's very similar to the list method. I'm going to start breaking down 75 into smaller parts by dividing. So I know that 75 can divide by 3, and that's going to give me a 25. Now I can't break 3 into any smaller pieces because it is a prime factor and doesn't divide anything other than 3 or 1. But I know I can break 25 into some smaller pieces because 25 divides by 5, and it leaves me with 5. Now, can I break 5 into any smaller pieces? Does anything other than itself or 1 divide 5? No, it doesn't, so it's a prime factor, and I've broken 75 into all of its prime factors, and there's nothing left for me to do. Now I'm going to do the same thing and make another factor tree for 100. So I want to break 100 into smaller pieces. Well, let's see. I know that 2 divides 100, and it gives me 50. I can't break 2 down anymore, so I'm done there, but I can break 50 down into smaller pieces. I can do 2 and 25. And 2 won't go into any smaller pieces, but 25 will, right? I know it's going to be 5 and 5. And I know that 5 is a prime factor, so there's nothing left for me to do. Now that I've completed my prime factorization trees for each number, to find the greatest common factor shared between them, I want to circle each prime factor they have in common, but I'm only going to write it down below once after I circle it. For example, I see that both numbers share a prime factor of 5, so I'm going to circle and cross out my 5s and write it down below once. And again, I see they share another 5, so I'm going to cross them out and write it down below once. Now 75 has a 3 in its tree, but 100 does not, so I can't write my 3 down. And 100 has some 2's in its tree, but 75 does not, so I can't write my 2's down. Now the last step to finding the greatest common factor is to multiply the numbers I have written below together. So 5 times 5 equals 25. And that's my greatest common factor. So the greatest common factor of 75 and 100 is 25. Either method will work for any whole numbers, so feel free to pick and choose the method that makes the most sense to you. Thanks for stopping by and learning something new today. If you would like to talk more in depth about the subject or would like some extra help with the concept, stop by the Tutoring Center at San Juan College for some one-on-one time with a math tutor. Don't forget to subscribe to San Juan College's Student Success Center's YouTube page for some more math help videos. Thank you and have a wonderful day.